Hey everyone, my name is Rachel Miner, and today we're going to be going over a few basic concepts about cancer. So what is cancer in the first place? Well, colloquially, we usually describe cancer as the unregulated growth of cells. Scientifically, though, we have a few hallmarks that kind of get more into the nitty-gritty of what cancer really is, because it's a very complicated thing and the combination of many factors. Some of those factors that cancer cells tend to have are sustaining proliferative signaling, evading growth suppressors, activating invasion and metastasis, enabling replicative immortality, inducing angiogenesis, and resisting cell death. Now, don't click away from the video just yet. I know those terms can be kind of intimidating and confusing, but that's what this video is all about, trying to explain in simple terms what all of those things are. So let's get started. First, we have resisting cell death. Essentially, when the DNA of cells has been severely mutated, the body is programmed to dispose of those cells. Think of this like if your computer had a virus on a specific program. Your first instinct might be to try and delete that program from your computer to stop it from spreading to all of the other programs on your computer. Now, if that program was a cancer cell, then as you try and delete it, you're simply unable to. Cancer cells are able to escape the defense mechanisms of the body, essentially making it so that they cannot be deleted. This allows cancer cells to continue to reproduce and spread throughout the body, creating more cancer cells with more mutations. Going back to our computer analogy, this would be as if you try and delete a virus on a program on your computer, and instead of deleting it, it actually spreads to more and more programs on your computer, making your computer more infected. The next hallmark is enabling replicative immortality. This basically means that cancer causes cells to be able to replicate even when they shouldn't be able to. This allows DNA to accumulate damage and mutations that normally it wouldn't be able to keep accumulating as it would have been stopped from replicating. This is usually when a checkpoint fails. Now, checkpoint is the scientific term, but we do have checkpoints in real life, and it's honestly very similar. Checkpoints in our cells usually make sure that the right cells are proceeding, the ones that don't have a bunch of mistakes, or it sends the ones with a bunch of mistakes or mutations off to get repaired. What cancer does is it essentially makes sure that this gatekeeper at the checkpoint is out to lunch when they're going. Instead of screening them and making sure that they don't go through because they have all of these problematic mutations, that gatekeeper is simply gone, and cancer can just kind of duck under the checkpoint and keep replicating with all of its mistakes and errors. This obviously creates problems as it creates more cells in the body with those mutations. Next, we have growth signals and cancer, and this actually is two hallmarks, but they're fairly similar, so I thought I'd group them together. These are sustaining proliferative signaling and evading growth suppressors. For this example, I'd like you to imagine the body as a car. Essentially, sustaining proliferative signaling would be like if you had a brick on your accelerator pedal. It means that your accelerator is stuck on. So if you look at this pathway, which is what we call these series of letters or names, you can see that A normally causes B, which causes C, which causes D. This would be like pressing on the accelerator pedal makes it so that your car goes. Now, if we made it so that A is no longer being activated, all of the things downstream should also not be activated, right? Well, what cancer does is it makes it so that C is constitutively active, or in other words, that brick is on the accelerator pedal and it's going to go no matter if you put your foot on it or not. This means that C still causes D even though the things upstream of it aren't present. Next, we have evading growth suppressors. This would be essentially like if someone ripped out your brake pedal so it just doesn't exist anymore. In this system, a cancer gene is never turned off. So in this pathway, we have A causing B, which causes C, but we have an additional letter, namely E, which actually inhibits C. That's what that little T symbol means in cancer bio. That means that E makes it so that C is turned off and therefore cannot cause D. Now, what cancer does is it actually makes it so that E cannot inhibit C. So that means that C is free to cause D even when it shouldn't be, because it should be being inhibited. This is obviously a problem, as it allows cancer to just spiral out of control and grow far more than it should. Next, we have inducing angiogenesis, and I know, what is this sci-fi seeming term? Well, angiogenesis is essentially the creation of blood vessels to bring oxygen and nutrients to an area. So the way to think about it is our blood vessels carry blood, and that blood carries with it oxygen and nutrition. Cells need both of these things in order to survive, kind of like we do as a general being. Now, cancer will make it so that it creates its own blood vessels to the rest of the body, so that the body has to give it this nutrients and oxygen even when the body doesn't want to, because quite clearly the body does not want to help cancer along. A good way to think about this in less scientific terms, as this is fairly complex, is it would be like a hacker plugging into a company's power supply and Wi-Fi as they are working on hacking into that very company. Clearly, the company does not want them to be using their power supply and Wi-Fi to hack into them. However, the hacker can do so anyway, and in so doing, use their resources to further their own malicious goal. The other thing about angiogenesis to mention is that it can be used as highways for cancerous cells to invade the rest of the body. This is essentially because just like that nutrients and oxygen can go through the blood vessels, so too can cancer, and it can just kind of go into the blood vessels and use them to metastasize or spread throughout the rest of the body. Now, I mentioned metastasize, and I'd just like to go over what we call metastasis very briefly. Metastasis, or metastasis, or however you've heard it, is essentially how far cancer has spread throughout the body. If you've ever heard about metastatic cancer, that is cancer that has spread throughout the body. Now, there is a general stages that we think about cancer in, which we think about in the TNM system. These letters stand for tumor size, lymph node progression, which is the N, which is weird, and metastasis, which is the M. Tumor size and metastasis we just got into, but progression into lymph nodes you can essentially think as another highway through the body. The lymph nodes are part of the lymphatic system, which, similar to the blood vessels, are something that cancer can get into and use to transport itself throughout the body. Now, with this TNM system, there are several stages. First, you have stage 0, and it's important to note stage 0 is actually not cancer, but it can progress to it. Stage 0 is when you have abnormal cells present. By abnormal, I mean having some of those various hallmarks that we just discussed, but those cells haven't spread into any nearby tissues, so it hasn't even gotten to the general tissue yet. It's mostly at the cellular level. Stages 1 through 3 are measures of how big or how spread out the tumor is. It's determined by a combination of these factors. So essentially, the bigger and more spread your tumor is, the higher your stage is going to be. And of course, stage 4, the most problematic kind of cancer and the worst diagnosis that you could hear in terms of this disease, means that there is distant metastasis, which means that the cancer has spread throughout the body. Often this is problematic, as cancer can often metastasize from an area where it on itself would not be problematic, like the skin, to some place like the brain, where suddenly you can see all sorts of problematic complications. This is why stage 4 metastasized cancer is such a vital problem facing society today, and why we often want to try and treat these people as best we can, even though we don't have as many methods to treat them. Anyway, that's it. Those are all the main hallmarks of cancer. Thank you so much for watching, and I hope you have a wonderful day.